In this situation, an object has been kept on a rough horizontal surface. This horizontal surface has a coefficient of friction mu associated with it. The object was given an initial angular velocity omega naught and no linear velocity. So essentially what is going to happen at the point of contact is that the point of contact will have a tendency to move in the backward direction. So this is the tendency of motion for the point of contact. So the friction force is going to get applied in the forward direction. So this is where the friction force will get applied. Alright. So what is friction doing in this particular question? Friction force is going to increase the linear velocity and decrease the angular velocity. Why? Because like we have discussed, the aim of the life of friction force is to have zero relative motion between surfaces that are in contact with each other. So friction wants to aim for the situation wherein V will become equal to R omega. We can understand and see that in this particular scenario, omega is initially greater. So in the initial case, omega is equal to omega naught and V is equal to 0. So friction would try to help V and would try to elevate V to such a level that it becomes equal to R omega. At the same time, friction would try to reduce omega such that V will become equal to R omega. So friction is helping whoever is lacking in between amongst V and R omega, whoever is lacking in magnitude, friction is trying to help that guy out basically. That is what is happening. Alright. So if I write down the equations, then what do I get? The force of friction is naturally going to be equal to mu mg. Why? Because kinetic friction is acting. So the force of friction is going to be equal to mu mg. Now this force of friction is acting in the rightward direction as explained. So the acceleration will also be in the rightward direction, and because of that acceleration some velocity v will come as a function of time. The force of friction is constant and the acceleration that happens because of the force of friction is simply force divided by mass. So the acceleration is simply going to be equal to mu g. The velocity that this will impart onto the object is going to be equal to v, which is going to be equal to 0 plus at, because initial velocity in the horizontal direction happened to be 0. So v is equal to 0 plus at. So that means I get v is equal to mu gt. This is one equation that I have. Let me label this as equation. Let us say I am labeling this as equation 1. This I'll label as equation 2. Alright. Now let us analyze angularly, as far as rotational motion of this object is concerned, what is the role of friction and what is happening there. So friction force is acting in the forward direction, and hence the torque provided because of friction will be counterclockwise, this torque, and omega is clockwise, so torque will oppose omega. And what is the torque provided by friction force? The torque provided by friction force is going to be equal to Fr. This will result in an angular acceleration alpha. So Fr is going to be equal to I alpha. There is no other agency or force that is providing any other kind of torque. Friction is the only one. Alright. So alpha thus is equal to mu mgr, because mu mg is the value of friction as aforementioned. So mu mgr divided by I. This is alpha. Alright. What will this alpha do? As discussed earlier, alpha will try to reduce omega, because here friction's role is to reduce omega and increase v, because initially v was 0 and omega was omega naught. So omega will now be equal to omega naught minus alpha t. This is the circular motion kinematical equation for situations with constant angular acceleration. So this is going to be equal to omega naught minus mu mgr upon I t. Omega will be equal to. So this is our equation number 3. If we were to find out the time at which pure rolling starts. Let us say if we were to find out that time, then in that case we would have to write down v is equal to r omega. Like this equation we would have to write down for the pure rolling case. That means mu gt is going to be equal to r times omega. That will be r omega naught. Okay, I am using equation number 2 and 3 simultaneously. So r omega naught minus mu mg r square t upon I. Now if I isolate the terms having t, then I'll get mu g into bracket 1 plus mr square over I. So okay, this kind of a scenario is equal to r omega naught, and yes, of course t is also there. Alright, so after simplifying this, we get t to be equal to r omega naught upon mu g, a similar looking answer to what we have previously derived in another situation. R omega naught upon mu g into I upon I plus mr square. So this is the time after which pure rolling will start, after this particular time. Now if we are to find out the velocity, then we have to plug in this time over here, and if you have to find out the angular velocity, we can plug in this time over here, or find the velocity and then divide it with r to find the angular velocity. Alright, we can also analyze this situation with respect to a point on the ground. Let us say any point x, let us say on the ground, to find out the final linear and angular velocity directly. That is also possible using angular momentum conservation. Angular momentum is going to be conserved about any point on the ground. It is necessarily going to be conserved because friction force passes through that point and normal reaction and gravitation are cancelling each other out. So there is no torque about the point x, and hence angular momentum about the point x is going to remain conserved. Now let us analyze and write down the angular momentum conservation equation. Initially the angular momentum is going to be equal to just I omega naught because no linear velocity was given, and finally the angular momentum is going to be equal to I omega plus mvr. Now let us say we are to find v, then omega can be written as v divided by r. So this will be v divided by r plus mvr. So this is going to give me I plus mr square upon r whole into v. This is nothing but I omega naught. Therefore v is going to be equal to I omega naught r upon I plus mr square. This is going to be v. Alright, this same v we would have obtained if we had substituted the value of time into the equation for v in the analysis that we did a moment ago. Now if we are to find out omega, we simply divide by r this particular value of v. So omega is nothing but v by r, and on dividing this right hand side expression with r, we get I omega naught upon I plus mr square. All these equations are also dimensionally correct. It is generally a good habit to develop to check the dimensional correctness of the equations and the analysis that we are doing in order to just make sure that we are accurate.